The definition of a base, a substance which reacts with acid to give salt and water. But this one is also the definition of alkali. So for base, you have to say metal oxide or metal hydroxide that reacts with acid to give salt and water. So that would be a complete definition of base. So complete definition of base is any metal oxide or metal hydroxide that reacts with acid to give salt and water. Okay, so that is the definition for base. So for base is anything, the first part of the name of a base should be a metal, the second part of it either be oxide or hydroxide. Okay, an example would be calcium oxide. It's a base. Calcium is a metal, oxide, so calcium oxide, or maybe calcium hydroxide is also a base. And when the base is soluble in water, that is known as alkali. Okay, when the base is soluble in water, some base may not be soluble in water, so only base that is soluble in water is known as alkali. That means all the alkali must be base, but not all the base must be alkali. Now let's look at the example here. Now sodium oxide plus water, you get sodium hydroxide. So the base in this case is sodium oxide and sodium hydroxide. The alkali is also sodium hydroxide and sodium oxide, because this sodium oxide dissolves in water. So sodium oxide itself is a base, but since it dissolves in water, it is also known as alkali. So this sodium oxide, it's a base, it's an alkali. Same thing with sodium hydroxide. It is also a base because it is a metal hydroxide, but since it dissolves in water, it is also an alkali. Now let's look at this copper oxide. Now this copper oxide doesn't dissolve in water. Okay, so copper oxide is a base. Why? Because it is a metal oxide. Okay, because all metal oxide is a base, so copper oxide is a base. But because copper oxide doesn't dissolve in water, so it is not an alkali. So copper oxide is a base, but not an alkali. Sodium hydroxide is a base and alkali. Why is it a base? Because all metal hydroxide is a base. Now, this sodium hydroxide can dissolve in water, therefore it is also an alkali. So sodium hydroxide is a base and an alkali. Same thing with sodium oxide. It is a base. Why? Because all metal oxide is a base. So sodium oxide is a base. Sodium is a base. Oxide, so sodium oxide is a metal oxide, so it is a base. But because sodium oxide dissolves in water, it is also an alkali. So sodium oxide is a base and alkali. Sodium hydroxide is a base and alkali. Copper oxide is a base but not an alkali, because it cannot dissolve in water. Okay, now let's look at the alkali, the application of alkali. Now alkali can be used to make fertilizer, detergent, soap, toothpaste. All these are the example of application. One thing to take note of is that for this alkali, okay, calcium oxide is an alkali because calcium oxide can dissolve in water. Now basically, how do you know what are the base that can dissolve in water, what are the base that cannot dissolve in water? So basically is all the group 1 and group 2 base can dissolve in water. Okay, all the group 1 and group 2 base, group 1 and group 2 base, they all can dissolve in water. So all the group 1 and group 2 base are also known as alkali. Calcium is group 2, so calcium oxide can dissolve in water. Now this calcium oxide, it's an alkali and it is used to neutralize acidic soil. because there are a lot of places whereby the soil is quite acidic, so people use calcium oxide since it is an alkali. Alkali and acid is a neutralization reaction, so they use calcium oxide as an alkali to neutralize the acid. Now let's look at the reactions, the chemical reactions that involve alkali and base. Okay, basically it's alkali first. So for base is just reactions involving base. Basically it's base plus acid, salt and water. So for alkali, first one, react with a solution of a metal salt to give metal hydroxide and another salt. So whenever there is an alkali like sodium oxide, sodium hydroxide, reacting with, this one should be reactor plus, reacting with a salt like this, metal salt like iron sulfate, iron chloride, potassium chloride, you know, so all these are salt. Whenever you have an alkali with a salt, they will swap partner, as in sodium. Right now sodium's partner is hydroxide, so it will swap partner, it would get sulfate, sodium sulfate. And then iron's current partner is sulfate, so it would swap, it would grab sodium hydroxide partner, which is hydroxide, so iron hydroxide. So the condition for this reaction is the reactants must be, one of the reactants must be an alkali, the other reactants must be acid. Must be a salt. One reactant must be an alkali, the other reactant must be a salt. Another example would be, so alkali, magnesium hydroxide is an alkali. So you have an alkali, and then the other reactant must be one alkali, one salt. Give me a salt, calcium sulfate. This is a salt. Okay, alkali and a salt, they would swap partner. So because right now your magnesium, the partner is hydroxide, your calcium, the partner is sulfate. So magnesium will get sulfate as the partner, and then calcium will get hydroxide as the partner, and it is balanced. Okay, alkali and a salt swap partner. This is the first reaction that involves alkali. Another reaction that involves alkali would be when alkali is heated with ammonium salt. Ammonia is given off. So you have an alkali, you have an ammonium salt. Ammonium salt means ammonium chloride, an example. Ammonium sulfate, another example. Ammonium nitrate is another example. So as long as you have an alkali and an ammonium salt, and then you heat it, you get ammonia gas, salt and water. So this is an example. You have an alkali, calcium hydroxide, group 2 hydroxide is an alkali, plus ammonium salt, in this case is ammonium chloride. So you get a salt, calcium chloride, water as well as ammonia. You have to heat it. So in this reaction you have to heat it. Okay, and then of course alkali would react with acid to form salt, water, and this is called a neutralization reaction. So neutralization reaction is acid plus alkali to form salt and water. Okay, this is an example of neutralization reaction. You have alkali, you have an acid to form salt and water. Now this is the Ionic equation for neutralization reaction. For any neutralization reaction, that means for any reaction involving acid and alkali, this must be the Ionic equation. Okay, I can give you another example that involve acid and alkali. You can have, okay, acid, nitric acid plus alkali, calcium hydroxide is an alkali, and okay, you get salt, which is calcium nitrate, and you get water. Okay, so this is actually an acid alkali reaction or neutralization reaction. If you write the Ionic equation, okay, which involves some steps here, the Ionic equation that you get at the end must be like this. Okay, that's why I say just now, this H plus plus OH minus give you H2O. This is the Ionic equation for all the neutralization reaction. For all the reactions that involve acid and alkali, the Ionic equation must be like this. Remember this.